Welcome to the first video for Further Mechanics 1 textbook. The first chapter is about momentum and impulse, and we're just going to do the first two exercises as we're concentrating on the AS course at the moment. The third exercise we'll talk more about at the end of video 2. So just to start with, we're going to look at momentum first of all. I'm sure this will be a revision again from your science GCSEs. You should know that the momentum of a particle is made up from the mass and the velocity, so mass multiplied by velocity, and it is just worth noting that the units of momentum are Newton seconds. It is also worth noting that momentum is a vector quantity, so direction is always crucial, really, when you're looking through all of the examples that we'll be looking at shortly. So I will come back to that when it's relevant, but just please be aware that momentum is a vector quantity. So example number 1, first of all, we're just told for part A that find the magnitude of momentum of a cricket ball of mass 400 grams. So that's 0.4 kilograms. We must change our units to kilograms and meters per second. And it's moving with a velocity of 18 meters per second. So therefore the momentum of the cricket ball is simply going to be 0.4 multiplied by 18, which gives us an answer of 7.2 Newton seconds. In the second part, part B, we have a lorry of mass 5 tons. So this time the mass is 5,000 kilograms, and that's moving with a velocity of 0.3 meters per second. So again, the momentum is going to equal the mass, which is 5,000, multiplied by the velocity, which is 0.3, which gives us an answer of 1,500 Newton seconds. So some examples that are fairly simple to start with. Now when we look at example number 2, brings in the idea of impulse. Now impulse can be given in two ways. It's either the constant force acts for a time, t, and that defines the impulse of the force as force multiplied by time. Or you can also think of impulse, particularly when we look at collisions in a moment, where impulse is given as the change in momentum. So if you like, mv, the final momentum, minus mu, the initial momentum. So impulse can be found out in either of these two circumstances. So part A looks at the first example. So we have a body of mass 2 kilograms. Is initially at rest, and a horizontal force of 4.5 newtons acts on the body for a time of 6 seconds. So find the magnitude of the impulse given to the body by the force. So therefore in this case we can say that the impulse is going to equal force 4.5 multiplied by 6, which gives us an answer of 27 Newton seconds. Obviously impulse is the change in momentum, so it's the same units as we have for momentum. And then the final speed of the body. Well, if the impulse we now know is 27, then we can also say that that is the change in momentum. So we have the final momentum is going to be what we're looking for. So we have our mass 2 times v minus the initial momentum. Well, obviously the body was initially at rest, so that's just 0. So therefore if we do 27 divided by 2, we get our final velocity of 13.5 meters per second. So that's two examples where you can use different values to find out the impulse of a collision. And then example number 3, I'll do this in two ways. So I'll follow the book's example first of all for you, and then show you why direction is important. So this time we've got a ball of mass 0.2 kilograms, hits a vertical wall at right angles with a speed of 3.5 meters per second. In other words, it goes into the wall with that speed, and it rebounds with a speed of 2.5 meters per second. And it asks you to find the magnitude of the impulse exerted on the wall by the ball. Now, with the impulse, we have a problem here, because the wall is obviously fixed. So due to Newton's third law, what we understand is that with any collision, the magnitude of the impulse exerted by the ball on the wall is exactly the same as the wall on the ball. So if we think about the impulse provided by the wall on the ball, it's obviously going to be provided in that direction because it's stopping it moving from there, and it's obviously rebounding back. So that is the direction I'm going to take as positive for my momentum equation. So what we have is mv, the final velocity. Well, the final velocity is in the direction I've chosen to take as positive, so that is going to be m multiplied by 2.5 minus m. Now the initial velocity is in the opposite direction, so therefore that is going to be minus 3.5. Okay, so as we said at the start, momentum and impulse, they're vector quantities, so we obviously have to take direction as the direction you've taken at the start of the question. So what we have here, the mass was 0.2, so therefore the impulse is going to be 0.2 times 2.5, and then it's obviously going to be plus 0.2 times 3.5, giving us an answer of 1.2 Newton seconds. Now, what I would say, you could look at it a little bit simpler than that. If the impulse is in that direction, you can see that the actual body, the particle here, has changed directions. So obviously to provide an impulse, for it to stop going one direction and then going in the other, you therefore add the two together. So it depends which way you look at it. But initially, we'll follow the way they do that in the book. So that's enough for you to get on with exercise 1A. So good luck with those questions, and we'll talk more about conservation momentum in the next video.